आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start this question. This question says, which of the following statements is or are incorrect? If the first statement is, if f plus g is continuous at x equal to a, then f and g are continuous at x equal to a. Second is, if limit x going to a of fg exists, then both limit x going to a of f and limit x going to a of g must. Third is, discontinuity at x equals a implies non-existence of limit at that point. Fourth is, all function defined on a closed interval attain a maximum or minimum value in that interval. So now let's look at the first statement. The first statement is f plus g is continuous at x equal to a. So let's take fx as just plus 1 for x greater than equal to 0 and minus 1 for x less than 0, and take gx as minus 1 for x greater than equal to 0 and plus 1 for x less than 0. Then fx plus gx, that is f plus g of x, that would be equal to, for x greater than equal to 0 we have 1 plus minus 1, that is 0, and for x less than 0 we have 0 again. So f plus g x is always equal to 0 for all x belong to R. So definitely f plus g is continuous. So limit x going to 0 of f plus g of x is equal to 0, and it is also equal to f plus g on 0, that is f plus g is continuous at x equal to 0, but limit x to fx, that doesn't exist, and so is the case for limit x going to 0 of gx. So both these limits don't exist, but the sum is continuous at x equal to a, and as these two limits don't exist, fx and gx are both discontinuous at x equal to 0. So this is a wrong statement. Moving on to the second one, let's look at this. So here we have a product, and then both limit must exist. So let's again take fx as simply x and gx as 1 upon x, then limit x going to 0 of fgx, that is equal to limit x going to 0 of x times 1 upon x, that is 1, which is finally equal to 1. But limit x going to 0 of gx, that is limit x going to 0 of 1 upon x, that doesn't, because it goes if from approaching as 0 approaches, as x approaches 0 from the right, it goes to plus infinity. As x approaches 0 from the left, it approaches minus infinity. So it doesn't exist. So this statement is also false. Let's look at the third statement. Discontinuity at x equals a implies non-existence of limit. Now, discontinuity at x equals a implies non-existence of limit. So that is not the case. If the discontinuity is of a removable type, then what happens is the limit exists. Limit x going to a of fx, that exists, but that does not equal a. That type of discontinuity is called removable discontinuity, and for that this statement turns out to be false. So this is also not correct. Let's look at the last statement. All functions defined on a closed interval attain a maximum and a minimum in that interval. Okay, so let's just take for that fx to be tan x if x is less than pi by 2 and greater than minus pi by 2, and for just let it be 0 if x equals pi by 2 or minus pi by 2. Let that be the definition of fx. So in that case, in the entire interval minus pi by 2 plus pi by 2, now we know as x approaches pi by 2, tan x goes to plus infinity, and as x approaches minus pi by 2, tan x goes to minus infinity. Therefore, there is not even a maximum or a minimum attained on this interval. So the last statement is also not true. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।